So today we're doing this solving multi-step equations, and I can give you a second to write that if you want. I'm going to start out just with an example, and you probably don't really need to write the example. If we had a problem like 3 times 4 plus 2, and that equals something. If we wanted to solve that, we do order of operations, right? We do parentheses, and then exponents, and then multiply, divide, add, and subtract. So that's kind of the order we have to connect those things in, yes? So if we're going to do this, first we have to multiply. You get the 3 times 4 is 12. And then we do the plus 2. Combine those two together, we get 14, yes? So if we have this exact same problem, but let's say we don't know that 4. Let's say instead of 3 times 4 plus 2, I have 3x, 3 times x plus 2. And let's say we know the answer is 14. We want to work backwards and say, well, how do we find that this thing here is going to be my 4? You with me? Order that you do things in matters. That essentially we're trying to work from this 14, we're trying to work backwards to figure out that number right there. So the first thing we have to do is we have to undo our step right here. We have to undo adding 2. To undo adding 2, you would subtract 2. And when you do that, you get a 3x equals 12. And now we need to undo the step that we did right here where we multiplied the 3 and 4. The inverse of multiplication is to divide. So instead of multiplying by 3, we're going to divide by 3. And then we'd come up with that our x value is 4, which is what we had in the little circle. Agreed? Almost ready for you. So the point is, if you're trying to take an expression like this here, and you're trying to evaluate it, you're trying to figure out what number does it equal, you do order of operations from left to right. If you're trying to take and do that backwards, you know what it equals, and you're trying to find out what number here would get you that. Now we have to do order of operations backwards. We first did our adding and subtracting right here. After you do adding and subtracting, then you do the multiplying and dividing. So you see how we're doing order of operations from right to left? So for how to solve these multi-step ones, I'm going to have 3 rules. And if you take these 3 rules, you should be able to go through and pretty much solve all of them. The first step, the first rule, I'm going to skip that, come back to that later. So the second rule is going to be the order. That if you have multiple steps, making sure you do those steps in the right order matters a ton. So I'm just going to do my PE, the PEDMAS. Please excuse my dear Aunt Sally. But you have to do that backwards. So I'm going to say backwards when solving for, I'll write a variable. If you want to say x, you could, but sometimes the variable won't be x. But the first thing you have to make sure you do correctly is that you're doing the operations in the right order, because you'll get a wrong answer if you do them in the wrong order. So number 2 is one of the new things today. Number 3 is really just kind of a repeat of what we did in the last 2 sections. And I'm going to say that's do the inverse operation to both sides. So do the inverse operation to both sides. So if you look up on your paper, that first example, it was a plus 2. So we did the inverse of adding 2, we subtracted 2. And it was x times 3, so we did the inverse of multiplication, we did division. Does that make sense for rule number 3? So we just want to look at a couple examples and start out with kind of some pretty looking ones, and then we'll get into number 1 we're getting to soon. So first example, something a little more normal. If I have a 5x minus 9 equals 46. Well, we have to do the order of operations backwards. So we start with adding and subtracting. So we have to first move this minus 9. Start out by doing the plus 9. So if I do plus 9, so to do the same to both sides, that gives us 5x equals 55. It was x times 5, so divide by 5, because dividing is the inverse of multiplication. Final answer would be x equals 11. And like in the last couple homework assignments, this is what I'm looking for from you, that you'll start out by writing out what the book gives you. Here's the original equation. Show what you do to both sides. Here's what you get. Show what you do to both sides. Here's what you get. So to get full credit, I'm looking for all those steps again. If we do another one, let's say I have example 3/4 x. Throw a fraction in there, try to make it a little dicier. 3/4 x plus 2 equals 5. First step to both sides, anyone want to holler it out? Minus 2. So, yep, you first say, is there anything connected by addition and subtraction? We have the plus 2. So we do the inverse of adding 2, just like you said. You get 3/4 x equals 3. Now this was the one yesterday I went through. Here's 3 ways to solve it. Somebody just pick one. What do we want to do to this thing? Go for it, Franklin.
I like to...
Okay, so he's going to do it in 2 steps. So he first gets rid of the denominator, and that leaves by multiplying by 4. So that leaves us with 3x equals 12. And then last but not least, we would divide by 3. So that avoids having to divide by a fraction, so that's kind of nice. X then is 4. Otherwise, you could have, if you wanted to, right at the beginning, said, all right, I'm going to take, I guess not at the beginning, at this step here you could have divided 3 by 3/4, which is the same as multiplying by 4/3. So if you prefer that way, go for it. This way here is sometimes a lot easier to see.
The answer is 4.
Yep, so the answer would be x equals 4. And what we're supposed to do, but most of us don't, is take this 4 and put it in right there and check our work. And if you did say I had a 4 right there, you could check it with saying in this case at least the 4's would cancel, leaving you 3 plus 2, which does equal 5. So it's wise to check your work, but a lot of us just are too lazy to do it, I think. A slightly more exciting example, and this gets us to that first rule that I didn't have written down earlier. If I have 15x plus 2, wait for the exciting part, minus 7x. What's up? Okay, equals 34. What's our new first step going to be? Take it away, Isaac.
Since there are 15x and 7x, you have to do 15 minus 7.
Perfect. And that,
X plus 2.
nice. So he sees that you can take and combine those like terms, that we have 2 different x terms. So 15x minus the 7x, because you say, all right, this is a positive 15x, this is a minus or a negative 7x, you could say. Gives you that. We still have the plus 2 equals 34. And now it's just a problem like what we were doing before, agreed?
Yeah.
So before we finish this, I'm going to jump up above, way up here to my rules and say, for my rules, number 1 is, combine variables. So combine variables if necessary. Because sometimes you don't need to combine variables because they already have them. Now, I want to make a quick comment on those combining variables. Something that starts messing people up is, well, here it's like I wanted to move my 9 to the other side, so I added 9 because they had subtraction. But then in this last one, we didn't do the opposite sign. That some people, they look at this and they want to say, okay, I have a minus 7x, so I need to add 7x. Well, you do the inverse if you want to take and move something to the other side of the equals. Because the 7x and the 15x are both on that left side of that equals sign, you just combine them the way they are. You only would do the add 7x or subtract 15x if you wanted to move it to the other side of the equal sign. Does that make sense to people? Okay. Then let's quick finish this one off. So with this, it's not 8x squared because it's not multiplication. If you had something x times something x, then that would give you x times x and x squared. But because you're just adding or subtracting, it's kind of like you have, we'll say 15 of these numbers. You have 15 x's. Now you're just taking 7 of your x's away. So you have 8 x's. You don't do the squared. Good question. All right. Then, now do we move the 2 or the 8 next? 2. So we're doing order of operations backwards. We always do our adding and subtracting first when solving for variables. So 8x equals 32. Last step then we would Nice. Divide by 8. So then x equals 4. And if you would take that x equals 4 and put that in for both x values and do 15 times 4 minus 7 times 4. So 15 times 4 plus 2 minus 7 times 4 equals, it would give you 34. Last example, we'll end with this for today. So I have example. This one, try to throw another curveball at you. I have 3 and then in parentheses, f minus 5, and then a minus 2 equals 4. And I think for this one it might be helpful to actually write out that whole, please excuse my dear Aunt Sally. So we're working left to right. So we first do addition and subtraction. So what do I do to both sides for starters? Add 2. That I have this plus 2. So when I rewrite it, I get 3 parentheses, f minus 5, and the parentheses equals 6. Now I can see where it might be tempting to say, all right, I wouldn't write this, but it might be tempting to say, I'm going to add 5 to both sides. The problem with that is that 5 is caught inside those parentheses, agreed? So we can't do that plus 5 until we get all the way over here to the parentheses part. We first need to do all of this for the stuff outside the parentheses. So we did our addition subtraction. Our next step is going to be to move what number? 3. Now there's really 2 options. One would be to do the distributive property and say I have 3f and then minus 15 equals 6. And you totally could do that. And we'll maybe do that a second way if you want. So if you want to work through it, we'd have 3f minus 15 equals 6. Do people see where my 3f minus 15 came from? For that, I'm doing 3 times f to get me 3f, and 3 times a minus 5 to get me the minus 15. Because it's 3 times that f minus 5 in parentheses, you could do distributive. There's nothing wrong with that. That's going to take you one step longer than just doing a little bit of a shortcut. What would be the shortcut for this? What number do I move next if I'm doing this left side down? Well, we did our addition subtraction. What's connected by multiplication or division? The 3 is, right? It's 3 times the parentheses. So how do I get rid of that parentheses being multiplied by 3? Go for it.
You would divide by 3.
Yep.
But couldn't you, before you subtracted the 2, couldn't you do the distributive property?
So final step solving it this way would be to do what to both sides? Add 5. So if there's 3 different ways to solve the problem, we should, no matter which way we do, come up with a f equals 7. If we had done it this second way over here, and write it, don't write it, it's really just personal preference. It looks very different as you're working through the problem, but you get a 3f equals 21. And then because it's 3 times f, we do the inverse of multiplication, we divide. And then you still get a f equals 7. And if we had right away at this beginning thing, right here at this one, if we had done distributive here, and then added the minus 2 to that, and then worked through and solved it all, you still would get f equals 7 if you didn't make any mistakes. So you have options. Just as you do the problems, be aware of kind of those 3 rules. If you have multiple x's, it's really going to be in your best interest to combine those variables first. And then once you're done with that, you always have to pay attention to the order and do the inverse operation on both sides.